Hi, how you
Good
doing,
morning.
sir?
Good. How are you?
A bit overwhelmed.
Oh, with what?
You probably haven't looked at NERF.
I've heard of it. Yeah, yeah. Neural rendering stuff.
Yeah, so basically computer graphics has gotten a hold of, I went to SIGGRAPH this year, I think I told you that. Yeah, so that's the big computer graphics conference, and there's about half the conferences on neural networks and how they approach computer graphics, and it's just so
Yeah,
much.
but just the other day I learned about how they made these what do you call it? How do you turn a vector graphic into rasterization? They just made, I mean, like a few years ago, they made rasterization differentiable, which with Bezier curves and stuff, which was pretty cool. Like I didn't know you could do that.
Yeah, no, it's so do you know what a NERF is?
Just heard about it. I never read the paper. I know
So
it's
the
a
idea
huge
is
deal.
it's crazy. So for every voxel in space, there is a neural network that is trained, a small one,
Okay.
that learns what light to show given incoming light. So if I shine light on this voxel and I view it from this angle, the neural network will learn what to show.
So at every instant, you're basically doing inference with like hundreds or thousands of neural networks?
Yeah, so they do what's called ray marching. So they march from one voxel to the next. And each time they go into a new voxel, it's a new neural network.
Cool. I should read that. Yeah. It seems like something you can use for like other simulations as well.
Yeah, so anyway, that's so last year. Oh. What they're doing with it now, it just bends the mind. So you can take a bunch of photographs from the internet and reconstruct a three-dimensional object, its specularity, its color, and its shape. Or a bunch of photos from the internet. Like, really?
Can you get the weight? I remember somebody approached me like a couple of years ago. They wanted to pay me if I could solve their problem. I think it was for farmers or something. They wanted to know, can you tell like the weight of an apple or some other fruit just by looking at it? So just take a picture and then it tells you the weight. I mean, but it wasn't apple. It was like a wide array of any object. Like somebody shows you an object, can you tell the weight?
You can certainly train a network to do that, yes.
Yeah, but I mean, you need a data set of the weights and the things, which we're going to maybe use Amazon to do, right? Because Amazon products all come with weight and things. They can probably scrape their website to get all the weights and things. But he thought that if somebody could solve that, it would make millions of dollars. But
yeah, so hi, Rob, how are you? Sorry, I'm kind of talking over you. You're muted, but are you there? Oh, sorry.
Yeah, I can hear me.
Oh, yeah, that's great. No, that's fine. How are you?
Good. No, I'm just trying to, I had to recreate part of that file.
Oh, I'm sorry. No, I'm totally keen to. Yeah, so the process du jour these days is unsupervised learning using autoencoders, right? So you have an input and then you just train an autoencoder to reproduce the input given the output and squeeze the latent space down as small as you can. And that has been producing spectacular results, like stable diffusion. I have stable diffusion running on my machine, by the way. It's a very easy setup. If you've got Anaconda, I would highly recommend playing with stable diffusion. It's DALL-E's big brother, and it's extraordinary.
so do they give you the weights and everything so I can just do it locally in my machine?
Yes, yes.
Okay, okay.
Yeah,
How big of a memory do you need to get everything?
You need a bit. Yeah, I've got 12 gig. I'll give you a sense of it though. I'll just share my screen.
I guess you played also with Dolly. Is this as good as the Dolly?
It's better.
It's better.
It's different. It's different. Okay. There's some very good online comparisons between DALL-E and Stable Diffusion. So let's do, what's a good one? Well, actually, I think before I do this, I'll just show you one. I did actually work up one. So just one sec. Where's that? And downloads. How's the? I'm genuinely interested. How's the information theory stuff coming?
Yeah, it's great. I actually just found one of, I didn't know, it's a couple of years old now. Like, do you guys know Sean Carroll? Have you heard of him? He's a physicist. He works, like he's a theoretical physicist, but he also is a popularizer. He has a podcast, he has a bunch of, so he had done a series of videos about the biggest, I think it's called The Biggest Ideas in Science or something. There's like 30 of them or something, each 1, 2, 3 hours. It was a couple of years ago, but I just came across one he did on information and entropy. And that was really, really good. Like, he'd answered a lot of the question confused, and he actually really addressed why people are confused about it. So he gives 4 definitions of information that came out in different academic circles and different times. And actually 2 of them are exactly opposite of each other, if you think about it. And that's what's making people confusing. So just watching that, it is for like a lay audience, so it doesn't go into a lot of detail, but it was really good.
Oh, okay. Well, can you share the link, please?
Yeah.
Like that. Would be awesome.
You need to be a bit patient. I think it was a couple of hours, 2.5 hours or something.
Oh, that's fine.
But he's a really good lecturer, and yeah, his podcast is my favorite one. He releases a podcast every week.
Oh, wow. Okay. Yeah, so check this out. So at the top, so every prompt is just some name of some artist painting a giraffe standing next to a clock tower. Right, so it's the same prompt every time. Okay, so there's Salvador Dali at the top. There is Vincent van Gogh, and so on. Stained glass window, photo real, Gaudi, Pissarro,
Wow.
Matisse, Warhol,
Do
Botticelli.
you have to give it text, or can you give it like an image and
So there's a
text?
different version, which is what's called image to image, and you give it a hand-drawn shitty sketch,
Okay.
and it will turn that into a Dali or a photo real or whatever you want.
Well, yeah, I know about like the neural transfer, but can the Stable Diffusion do it?
Yes.
Oh, that's part of the thing.
Yes.
Okay.
Yeah, you get both.
But you have to sketch it, or it could be any input.
I mean, I'll show it to you. Let me fire it up and we'll play with it together. I think that would be a useful thing to do. Thank you for that. I'll check out that link. You need to fire up a different version of the Stable Diffusion. That was what's called text to image, and I'm just going to run image to image.
Well, maybe I'll fire that up this weekend and play with it.
Yeah,
You
yeah.
have a contract with a big company. I guess I probably shouldn't say the name, but they're designing an office space in Calgary. And so they have this fishbowl kind of meeting room in the center. So inside of it, they're turning it into whiteboard for people to write. But outside, they want to create some kind of AI generated art. So I'm working with their graphic designer to basically using neural style transfer, like the old version. So I didn't know that DALL-E could also do that, because they have some images that they want to use, but they're open to making it AI generated somehow. And yeah, so I'll try this and see if it works.
Okay, so let's draw a picture together then. So let's bring up a whiteboard and draw a picture together, and then I'll shove it in and we'll see what we get. So I'll just fire up the whiteboard. Okay, so I'll do the sun in the sky, and let's just make it about this big. So draw some stuff in the image, and then we'll give it to Stable Diffusion and see what it comes up with. So I'll do the sun. Grab a pen and off you go.
How do you grab a pen?
Can't you write at the whiteboard? You can all write on the whiteboard. Sure you can. Don't you at the top have a little toolbar with draw and stamp and other stuff?
I don't have it.
I think only one can drive it.
Really? Well, that sucks. Oh, anyway, okay, so I'll draw a shitty picture, right? I'll draw some stupid, mountains in the background. Some birds in the sky. And
It's birds.
house. Yeah, so here's my house. You like my house? It's very nice, isn't it? It's got windows at the top. Okay, all right. So I'll take this fine piece of art here and we'll shove it into text, image to image and see what we get. So I'll just chop this out. And save that. Okay. And reload this. So we have to give it some text. So I'll just drop that picture in. So let me share my screen again. This one here. Downloads. Drop my scrap in there. Okay. So let's say Matisse. Matisse painting on landscape. And we'll do 5 versions. Oh, yeah, let's do a bunch of different versions. And off we go.
That's the maximum resolution you can do.
Depends on your RAM. So I can do 512 by 512. I think I could go probably up to about 800 by 800, but yeah, no, it's RAM dependent.
What is the maximum the model can do?
The maximum, the model, I don't think there's an upper limit. It's open-ended. So however much RAM you've got, it will use. So I have no idea what we get. I've literally used this particular tool for about 5 minutes. Are you seeing the, yeah, you are, okay.
Yeah.
So yeah, so that kind of leads into this discussion of latent spaces. Let's bring up the other thing I wanted to show you.
There's another buzzword that's going around called outpainting. So
Yeah,
inpainting has been around.
Yeah,
the inpainting, I guess, for Rob, inpainting is basically you have a painting, you erase some part of it and then regenerate it. So the point is you make it consistent with the rest of the picture. But outpainting is the opposite. So you have a spot and you want to basically outwardly generate new things. So it's very open-ended, similar to this, and it seems to be all the hype, all the buzz right now.
Yeah. So I think actually the future is in latent space sculpting. In other words, trying to come up with ways that we can manipulate the latent space to give us what we want, rather than actually trying to operate directly on things, is to project our problem space into a latent space, which gives us the dimensions that we care about, and then reprojecting that back into something that we have experience with. So yeah, about half the papers I've been looking at on the SIGGRAPH side. Unfortunately, if you can get a SIGGRAPH, I can't share the videos, which is a real piss off, but there it is. I guess I could give you my login or scrape the videos or something, but about half of them, what they're doing is they're just manipulating, they're just projecting into latent space, adding some parameters that they care about, and then reprojecting back out of latent space to give them what they want. This manufacturing technique seems to be very powerful and very popular. So that's what I'm trying to wrap my head around.
So is that the architecture of the other images you showed, you know, the giraffe and clock?
Yes. Yeah. So DALL-E and Stable Diffusion are quite different.
How do they figure out what to...
Yeah, I didn't do a very good job.
How to tweak the latent space then?
So that's the black magic, right?
That's pretty complicated, I would think.
No shit. I'll try again, Pi. I'm sorry. I've only used that tool twice and it didn't produce a good result. I've got some spectacular results out of Stable Diffusion, out of the text, but I have not quite worked out how to use the image to image yet. Yeah, so okay, I'll show you this. So this is what I'm working on. Let me share my screen. So this is another problem that I'm scratching my head about that I'd really appreciate your input on. So this picture is incomplete. I'm just trying to wave my hands here. So we have let's say we have the same text prompt, but two different outputs. So I typed in, a picture of blah, 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 and it gives me different options, okay? The idea here is that, and I don't know why the thing is spinning, but anyway, is that you would put one image in here and one image in here, and then it would encode that image into the latent representation, and it would encode this image back into a latent representation. And then you're standing in front of your screen, and I'm using a model to detect your pose, and I can get your pose information, and then I can interpret your pose with yet another model. So now there's 4 models. And I can use your pose to blend those 2 latent spaces together and then generate a new output, which is an image which is neither this nor this, and is controlled by you. Does that make some sense?
Mm-hmm.
So what's going on here is we're model stacking, right? We're using models, and then we're taking the output of one model and we're shoving it to the input of another model, and so on. And to me, it's an obvious step to build this and use this to train one model, if that makes sense. So you can essentially, if you have a bunch of models that you stack together to solve some problem, you're now back in a situation where you can train again, right? Because the loss function is your complicated network, right? Your complicated stacked neural network. And that gives you ground truth, sort of. And then you can train another model that does all of this in one model, which is hopefully much more efficient and much less prone to bias, and is much more like, it's very black box because you're essentially encoding multiple models in one model. But to me, that seems like an obvious extension. If you can produce a stable situation where you have some reference input and you can generate a reference output and you can use those to train again, my understanding is that you can use that to train again, and then you've got again, and once you've got again, you don't have 1, 2, 3, 4, 5, 6, 7 models, you have one.
But the GANs are unsupervised, right? It's not a...
That's right.
Okay.
That's right.
So what was the application of what you just showed? So what are you trying to accomplish?
I'm trying to fly through latent space. So you, let me get this to work.
So what are the latent representation A and B? Are those 2 different images that you give, or is it the same image to 2 different models?
They have to have the same latent space, so they have to be the same model.
But different images.
But different outputs, yeah. So given some text, Buddha sitting on top of a mountain, right? You get 2 different images of Buddha sitting on top of the mountain, and they would go into the top, and then you would lean to the left and you would get that one, and you would lean to the right and you get the other one. But if you're halfway in between, it would be moving not in physical space but in latent space. So Buddha's face would be warping or something. I can give you an example of that.
But I guess the question arises, I guess there's probably infinite number of, not infinite, but very large number of directions you can go in your latent space. How can you capture that with the pose? We only have so many joints.
No. Okay, so this is my dirty trick, is that I'm linearly interpolating all of them. Okay. I'm just blending them, right? So if value of this dimension is A in this, sorry, if this dimension A is 1 in this one and 2 in this one, then halfway in between it may or may not be 1. I haven't tried this yet. These are just early thoughts. But
yeah, I mean, the pose detector, you can just download a model that's already been trained. You don't need to retrain it, right?
No, and I'm not going to. No, that's yeah. So and there's a bunch of them, right? There's Apple iPhone and the Connect and all these other ones. Yeah. So, and we've got some parts of this working. I can give you another quick demo of what we've been doing. Where is it? So, but So how does the encoding stuff, sorry to keep jumping back to it, I'm just very curious. Have you been able to solve problems using Huffman code, or?
I haven't gotten there yet. Yeah, I'm still trying to map my problem into a proper information. It doesn't quite map, it's sort of backward to what I need. So
Okay, so you still haven't overcome the conceptual.
yeah, and also my alphabet has 188,000 letters as opposed to like 32 or whatever 26 in English. So that makes it a lot harder. So I can't get my
Harder
actual
or just more
frequency.
computationally expensive?
Well, yeah, but it makes it harder to experiment with things. I might have to take a detour and create a smaller version of it with some fake stuff just to see if it works or not. Yeah, this time is not a, we don't have a time limitation. This is the kind of thing they do maybe once a season or once a year. So even if it takes whatever 10 hours to run, that's fine. But if you're developing something, it's kind of hard to debug if it takes hours every time you want to run it.
I see. So that's the main issue. I'm just curious, right?
I'm not even actually sure if the Huffman codes are the right way. I mean, Huffman is pretty easy, right? Like I mean, that it's the main intuition is clear that if it's something is more frequently used as alphabet, like letter E, you encode it with the shortest possible code. What I'm trying to do is backward. If an item is ordered the most often, I want to put it in most bins, not the least bins. So I guess it would be an inverse relationship almost. But then you need to make sure they are normalized and it makes sense.
Right. I understand. Yeah. Interesting.
Yeah, even with the alphabet, I mean, Shannon did some cool stuff, but so one way, the first order is to go at each letter and see how frequently each one is used in a English language. But then you can look at pairs of letters and see how each pair is used, how often, and you can keep going, right? And basically, in my case, I have to go up to 4. What 4 items go together? And that gets exponentially larger, right? Especially if you have 188,000. Basically, it gets, you can't even store it that number in memory. So I need to figure out a way to not have to do that. But yeah, I mean, Shannon, they didn't have like computers like today. So he came up with lots of clever ways to estimate these numbers for the English text. Like what are the 4 blocks of, like, for example, if you get like Q, you're almost like 100% that you're going to get U after it in the English language, right? But so that helps you that if you, as soon as Q comes, you already know what's coming after. So so this knowledge helps you encode how you want to basically translate English to a code.
Wi-Fi from Xfinity. Thanks.
Sorry.
Nope. That's fine.
How is your stuff going, Rob, with the clustering?
Yeah, it's I finally got a working data set now. I found a couple of problems in the earlier one I had sent David. And the problem was companies that went through a stock split. So what that did is to change the price. And I do the standardization at the company level. But if it's changing its price, then that standard deviation or standardization becomes screwy. You know, so you got, you know, a 2-for-1 stock split. So all of a sudden the stock price falls 50%.
Right.
So that changes the distribution, and that in turn kind of changes the output from the clustering algorithms. So at any rate, yeah, I got that. That's working now. And this is a kind of a test data set. I have to do it with a more complete group, but you know, it's pretty much the same types of results. So you've got, you know, a small number of clusters. They're pretty easily identifiable in a graph. And there does seem to be some sort of systematic transition between the clusters. And there does seem to be predictability over time within the clusters.
Yeah, so how would you approach that? Like you've got, my understanding is you've got 200 different, let's call them perspectives or views or variables that are attempting to represent some hidden function, right? So you have 200 different views. Pam, I mean, I have my own ideas, but how would you approach trying to make sense of those 200 different perspectives to, I mean, would we try and correlate them all so that we have one metric, which is kind of, if I take any other metric and I add noise, I get this one kind of thing? Or if I take my universal metric and then add some noise, I can get the other one?
You'll have to refresh my memory. What was the ultimate goal of this? You wanted to cluster similar things together, but...
No, the ultimate goal is to come up with a way of characterizing liquidity. And by that, we kind of mean how difficult is it to trade a stock? So if you can characterize that, and then if you can predict what the future clusters or classifications are going to be, then that's important information in figuring out how to trade.
Mm-hmm. So what is this liquidity? Is it a number between 0 and 1, or what is it?
We don't yet really have a good definition. That's actually kind of a separate question. So how would you take this information and really map it into, you know, some sort of meaningful index?
But,
yes.
but don't you, like, let's say you run your clustering algorithm now, you get some results. How do you know how well you're doing? Like, do you not know how well you're doing?
Yeah, I guess we don't really know how well we're doing. When I look at the clusters, it kind of makes sense. So, you know, there's going to be, when bid-ask spreads are low, they tend to be, and I don't know, you know, cluster number 2. When they're high, they tend to be in cluster number 4 or something like that.
Mm-hmm.
Yeah, so there's some nuance. So if there's depth in the market, in other words, if there are on either side of the current price, if there's a lot of interest in buying slightly lower and there's a lot of interest in selling slightly higher, then the market has what's called depth. So if there is a shift, you'll essentially be able to tap into a large pool of demand or a large pool of supply. And so you'll get a lot of movement, which is what liquidity is defined as being. So when a lot of money is moving, it means not only is the price here, but there's depth on either side, or at least depth on the side that it's going to move to. And if there's depth on the side that it's going to move to, then you'll get this liquidity event, which is a very, very large transfer of capital. So I don't know if that helps, but
yeah, I'm not sure I know how to deal with this. I guess this is, I would say you still need to work on formulating what your problem is, because if you don't have a clear metric of what good or bad is, I mean, machine learning is not going to help you. There might be other ways of, like, if you have a clear model of what you want, but if you don't know exactly what you want and you can't measure it at all times, there's really not much you can do with machine learning.
Well, maybe not, because, you know, right now we don't have any way of characterizing in any kind of predictive sense of what the cost of doing something is going to be, you know, tomorrow, for example. So these characterizations don't have to be perfect. All they have to do is be useful.
yeah.
Yeah, but still you need to, like, if I give you a solution to your problem, you need to be able to tell me how good I'm doing. Otherwise it's just random. Why not just pick a random solution and hope for the best? And why would you trust some clustering algorithm that's spitting out? It's just looking at patterns between different features that you have. It means nothing, absolutely nothing. It's like you could generate random. I mean, you tested it yourself, right? You can make random numbers and cluster them and you get somewhat reasonable results, right?
Yeah. So that's kind of where the predictability part comes in. So if I can use information up to time t and generate cluster classifications, and then look at the time series of information in the clusters and use that to predict cluster membership at t+1, then that's where it's starting to be useful.
Yeah, but the problem I have is cluster membership means nothing until you specify something meaningful, right? Like it's pretty much random. Even if you run the same clustering algorithm again, you're going to get different memberships. It's not going to be the same. It just depends on your initial condition when you started running the clustering. So it means nothing. So cluster membership means nothing. So if there is a way you can use your up to t data points and use the t+1 data points and label it by hand, what you would have liked to see just given the first t data points, I think then you have a machine learning problem. But if you want to go based on a cluster membership that's part of the whole system, I don't know if it's going to go anywhere. I could be wrong.
Yeah, no, I mean, it's an important point. I guess I keep coming back to if the clusters are kind of stable and predictive over time, then why isn't that useful information? I'm not saying there's something out there that we can't find something that's better.
And no, I mean, if you get clusters that are predictive, sure, go for it. But how would you get it? I'm just saying if you run a clustering algorithm without knowing what's better or worse, you don't have it. You don't have the clusters. Like, what do you mean they're stable? So if you run...
I kind of know what's better and what's worse. So I mean, I can look at the different clusters and kind of rank order them, good, bad, and average, for instance.
Okay. So how do you do that in your mind? Like, isn't that something you can turn into labels?
Turn into labels. I suppose so. So I mean, when I look at the individual clusters, and I'm looking at, a couple dozen different measures and sort of, trying to juggle how they rank. And generally they wind up kind of lining up on the same side.
So why do you even work on the cluster level? So if I give you one of those data points with 100 features, like, can you just look at it for like half an hour and give your judgment of whether it's good, average, or better?
I would have to look at them in relation to the other ones, because I don't have a good sense of what's sort of good or bad. I mean, if I had a better sense of that, yeah, I could.
So then that makes it even more complicated. So you're saying whether or not a particular company is good or bad or average depends on all the other data points. So you don't even have the IID assumption that machine learning requires.
Well, no, I mean, I think that the IID part is probably okay. It's just that I don't know what on a bunch of these different measures, I just don't know off the top of my head sort of what's average, what's above average, what's below average.
Mm-hmm.
If I sat down and looked at it for half an hour, yeah, I could make that characterization, I bet.
So maybe one other approach could be look at pairs of coins and just decide which one is better than the other. So make a model that takes two companies and outputs which one is whatever has more liquidity, and keep doing that at random with different pairs and then use that for clustering. Is that enough to compare two of these, or do you need to compare one to many to come up with that judgment?
So yeah, I mean, I guess I don't, that should work also. So I've been really simple in this. It's just kind of a standard k-means approach.
So have you tried just running your k-means like 10 times? Do you get the same cluster, the same membership, or I would guess you would get totally different membership every time?
No, I think actually, yeah, I haven't tried that experiment. But I suspect it's going to be pretty close.
Okay.
So I was going down a different track. I'm just curious what you think of my track. So where I was going to go was what's called a master model. Have you seen master models, Pam? So you train each, okay, so first of all, I learned from my SIGGRAPH stuff that if you have periodic patterns in behavior, then you shouldn't use ReLU and you shouldn't use sigmoid, you should use sine. So there's been some incredibly successful prediction models in modeling physics animation, and I can share the papers, in which the loss, the function that you use to train your loss is actually a sine wave. Very interesting. So where I was going was I was going to try and use one of these models or an LSTM or whatever you like to predict each of the individual paths through time. And then the master model attempts to predict the 200. So if you say to the master model, this is happening in this trace, then it has an understanding of how that trace model works and can predict the model for that one, but it can also predict it for all the others. So the idea of where I was going is a little bit different. It's not clustering per se, is to create this master model motif where I have partial information. So I have these three or this one parameter of this path, and I can pass it up to the master model, and then it will synthesize corresponding values for the other 200 parameters. Okay, so that's a different approach, but where I'm going with that one is that this master model essentially is a model that covers all of the 200 parameters in a single model and can predict each of the, or reconstruct each of the individual 200 parameters from any others. And then maybe we can do something interesting with this master model. But that's what do you think, Payam? Does that make any sense to you? Or?
Yeah, I haven't heard of those before. I mean, the only concern I would have is, do you have enough data to do this? Like even LSTM, you probably need a lot of data, right?
Well, I wasn't actually suggesting that we use an LSTM, to be honest. I'm suggesting that we use the sinusoidal network, which is just a classic. I think it's just a fully connected perceptron, multi-layer perceptron. But that's where I was just going to tinker with that.
Yeah, I mean, there's another reason that approach, first I'd heard of it too, but another reason that approach is kind of interesting is that there's a sort of a branch of econometrics that is called panel data. And what it tries to do is look at individual individual units through time as a group. So that imposes kind of a different set of structure, I think, on the data than the one that you're talking about, David.
Right.
And yeah, it could be really interesting.
Yeah, so it's just very rarely do we have 200 different long-term kind of data series that are all trying to measure the same thing in different ways, right? So I think that that particular element of it's very interesting. The other thing we could do is just windowing, right? So we're essentially, we do the trick. So there was a company that was doing the reCAPTCHA when you move your mouse to click on the button, right? And it would draw a picture of your mouse movement. And then it would use a classic CNN to essentially look at that image, and its criteria was it's a robot or it's not a robot, right? So it was actually looking at time series data as an image, right? As a movement path on a two-dimensional surface. Perhaps we could do something like that where we take a chunk of this time series data and just render it as a one-dimensional image, if you will, and then see if we can essentially predict, given this part of the image, whether we can predict the other part or something like that. Not sure, but that's where I was going. A little bit different, but
It's interesting.
Yeah, I think all of these I think are valid, but I think still you need to work harder on getting your metric straight, or at least know if a solution is presented to you, immediately know whether it's good or bad or how accurate it is. Unless you have, until you have that, I don't think it makes sense to brainstorm approaches, because you don't have a problem yet. You just have a data set.
sure enough.
Sorry, you don't have a machine learning problem yet. I guess you have a problem.
So when you say machine learning problem, you mean classic backprop?
Supervised learning.
It could be unsupervised. You still need to know what is your metric. You're always trying to, it's an optimization problem. You're trying to optimize something. So what is it you're minimizing? What is your loss function? That's what you need to know before you can even start talking architecture or approach. Usually there is something you're optimizing for. So in terms of clustering, you're optimizing, I guess, for, yeah, there's the k-means loss that you're optimizing for. You have a distance and all that. So
well, what about this? I mean, would you feel better if I took the k-means clusters and simply said, okay, and this is now labeled data?
Well, I mean, people tried that. I mean, but the problem is it's usually not, right? It usually doesn't correspond to the labels that a human would ascribe to it. It would be more random. It would be based on things that you don't care about. You haven't told it what you want. So whatever you get, you're at the mercy of random chance or random structure in your current data set. It doesn't seem to correspond, it doesn't have to correspond to reality in any way.
Okay, so how would you then construct a clustering approach that would incorporate that type of information?
Well, that comes before, right? I mean, what do you mean by similar? What do you mean by different, right? So I guess the whole point of the supervised learning, it is kind of a clustering algorithm, right? If you look at the last layer of a supervised learning, let's say classifier, but basically all it's doing is transforming your feature space, let's say your 100 whatever parameters, to make it all into very clearly separated clusters. If you look at that, it's basically clustering it exactly into the classes you ask for, and they are very linearly separable. So if you do a good job, if your model is good, they're going to be very clearly thing. Whereas if you just plot those points, they're going to be all over the place. So you can use the clustering. If you don't have labeled data, you use the clustering algorithm, and it tries to do the best it can, finding things that are somewhat similar, but that similarity is completely random. Like it could be a particular structure in your data. So I don't know how you would be able to do that. So is there no way to get like any labels that you can vouch for, even for a smaller subset of your data set?
Yeah, I mean, you know, for a subset of it, yeah, you could certainly go through and try and label it like, you know, good or bad, something.
So is that enough? Like, is that at the end of the day, do you want basically a binary classifier that tells you if something is good or bad?
Well, given that we don't have anything, that would be preferential. I mean, it's if I can say with some measure of confidence that it's going to be bad tomorrow, then that's valuable information.
But did I understand correctly? Whether or not it's bad tomorrow depends on all the other companies and data points that you have.
Yeah, in some sense, yeah. There is, when I look at the data more closely, I see kind of two things. I see sort of an overall movement in these measures of ease, ability to trade. So like an overall market characteristics that has an impact on all the individual companies. And I also see on the individual companies some firm specific trends. So if you're looking at an Apple that's really actively traded, that's going to, liquidity on that is generally always going to be good. If you're looking at a inactively traded stock, generally it's always going to be not too good. So, but there are times when the inactively traded stocks all of a sudden start trading again, and some specific news relevant to that company. So, if on a company specific level, or perhaps even on a market specific level, if one can come up with a useful characterization of it. I mean, that's kind of the approach I was taking, not not thinking about, can I do something better, but kind of hadn't got to that part yet.
We do something at all. Yeah.
So, but again, I mean, Pam, so what would you suggest looking at then?
Yeah, I mean, if that's the case, so let's say you look at one row of your data set and the answer will change depending on the other rows of your data set, I think you're basically done. I don't think you can solve that with machine learning. Like, you need to do something else. But if you can assume that they're independent,
yeah, they're quasi-independent.
Yeah, so I guess you'll have to make that assumption, because otherwise your one data point is not that one row, it's actually your entire data set, and you need to get a bunch of data sets. Then each one of them will be your data set. And then you can encode all the rows as one input. And then you're trying to predict maybe something for one of them.
Okay, so if you're going to try and put that together, you could do something like you could have a overall sort of market variable or something trying to capture.
Yeah, so that's what I thought. Yeah, so that's why your input could be, let's say, one of the companies, and then all the other sort of rows will go into some model to give you some measure of how the market is overall. So it's conditioned on everything else, but then you care about the prediction maybe for one of them.
So, if you're going to look at trading volume, that's one measure of it. So it'd be easy to sum across all the companies and compute the aggregate trading volume and add that as a new feature.
Yeah, so you can do that. But is that already in your 100 variables?
No.
It's not, okay.
No.
Yeah, so I mean, it would be useful to do that. But I mean, again, it goes back to the original problem, like, how do you verify, right? Like, let's say you have something, it's giving you good or bad. Like, do you want to just look at it and judge whether it's actually correctly classified as good or bad? Or is there, I think at the end of the day, you still need some kind of a ground truth to verify. Even if it's historical thing, you want to cut part of your data and see whether or not you got it right. it's important to know how to evaluate your model, right?
Well, yeah, I guess I'm still kind of missing this because I can generate a prediction for tomorrow. If those predictions are more accurate than some sort of, random walk alternative.
Yeah, so that's a good way of evaluating. So if you could wait till tomorrow to get all the
Right.
results and then see how often you were right, and that gives you a number. But can you not do that based on your current data? Maybe cut off some part of the end and use that as a label of to try to predict. Like as opposed to, we don't want to wait till tomorrow. We want to like use the current data set and see how well you can predict.
Yeah. So in other words, what we do is do that sequentially as you go through the data. So you might use first 100 observations, generate a forecast for tomorrow, 101, and then sort of repeat the process. So now you've got a whole series of predictions that were generated that now can be compared to what the actual data was.
Yeah, exactly. So that could be a floating number if you want to do regression. If it's a number, you can put it on, or it could be good or bad. Yeah, so I think you can generate a labeled data set just with that, and then you have a very simple problem to try. It's a supervised learning problem. It might not work, but I mean, you can try. I think that would be probably the first thing to try.
Let's say that for me one more time. Sorry, I just want to make sure.
Yeah, so you create a labeled data set using your current data set by looking at what Rob was saying, let's say the first 100 points and then predicting the 101st point. So that window could also be a hyperparameter. Like we don't know, do you need 100 data points? Do you need 5? Do you need 10? Maybe you can repeat it 10 times to see which one is better. And then, yeah, so basically your data set now will become things that are 100 with a label of, let's say, good or bad, or some floating number, whatever, you can do that. And then you will have all the rows. And then you train basically a binary classifier on it and see. And then you can set aside part of your data if you have enough and just test it on that. So don't train on that, just test it and see how well you do on predictions. And then the ultimate judge would be what you set. Maybe try it for tomorrow's and see how good you get it over a consistent, whatever, next month or so. I think that's more likely to succeed than trying to do it completely unsupervised. Like unsupervised learning doesn't really work.
So it doesn't really work even in the case of a GAN? Sorry, that's a...
Well, GAN is a generative, it's a different story, right? You want to generate pictures, right? You don't know if it's working or not.
Need to be pictures, anything. In any situation where you're trying to create an autoencoder, you can use unsupervised learning to essentially encode priors.
Yeah, I guess by unsupervised learning, I meant clustering. Clustering, like that's almost like the last resort if there's absolutely no way that you know anything about your thing and you want to just be at the mercy of the, yeah, I mean, GANs is a different story.
Okay.
So if you try to do it with a GAN, so, okay, I guess you do it like on a company basis and you build, I don't know, some sort of autoencoder.
So given this, this pattern of behavior, try and squeeze that into a small model where if I give you the values that I encode from this pattern of behavior into this small model, you regenerate the same pattern of behavior. Yeah.
Yeah, so there are like GANs I just looked up. So this is like a survey article of GANs for time series. Yeah, I guess it depends on what you're trying to do. So this is a significantly more risky, difficult thing to get to work, and you also need a lot more data. So yeah, I would still suggest you try the simplest approach, just a binary classification with a supervised learning. And then, yeah, so this is more experimental, I guess.
For sure, and I'm not suggesting it's not, but we're getting some pretty spectacular results out of GANs in an unsupervised setting.
Yeah, but
where
spectacular.
we have a great deal of data and compute, right? So I'm not suggesting that training a GAN is either cheap or light on data. Neither. It is very expensive on data, and it's very expensive on compute. I think the cost of training Stable Diffusion was about $750,000.
Yeah,
Just
but you
to-
got to compare the goals too, right? I mean, you say spectacular results, but it's just it's for show, right? It's just a bunch of pictures. You're not trying to understand anything about your data or how the markets are going to perform, right? You're just going to generate pretty pictures. So that's the judge is it's a very different type of problem. Like I wouldn't say like it's almost hard to judge what is spectacular, right? It's a very subjective thing. So if you want to do something subjective, it makes more sense. But if you want to figure out what is the liquidity tomorrow is going to be, like, I don't know if I would go to GANs, but I mean, you can try it. As far as I know, Stable Diffusion doesn't predict anything about the future or about anything. It just generates things by interpolating between all your data points. I mean, you can try it.
Well, I don't have enough data to get really aggressive with it, but I'm interested in trying it, put it that way.
So how many data points do you have? Like, how many can you get? I guess that's what is the upper limit?
The history of the stock market. Yeah.
Okay, so the sample I got now is like 367 stocks, and I've got 252 trading days in a year and like 200 variables.
Okay.
Okay, so I could take that back further, but now kind of in a time series sense, the longer the time frame, the more chance there is for stuff to change, like, you know, the COVID episode. You can expand the cross section probably out to about 4,000.
Mm-hmm.
So I don't know, figure on, yeah, I mean, you know, if I'm going to focus on recent data, individual time series of roughly 500 data points.
Yeah, I mean, I think all of these are valid ways to go, like if you want to try GANs, but I think it's clear the steps you have to go through. Like you have to start with the simplest and then see what you get. At least you create a benchmark or like a baseline, and then you'll try to beat it with GANs or whatever else you want to try. But I don't think it makes sense to go to the cutting edge stuff before you even have a simple baseline.
So
yeah.
let me pose a question though. Suppose you're looking at one of these high dimensional data sets, and on a couple measures, the distance between two observations is really close, really small. And then for another one, it's pretty big for just, I don't know, maybe some idiosyncratic reasons.
Mm-hmm.
So is there a way of trying to ascertain which one of those dimensions you want to emphasize in terms of cluster groupings?
Yeah, so again, that's what the model learns, right? Based on what, I mean, you say so you have some idea of what you want in your head, but the model, the clustering model doesn't see it, right? So that's why if you have a label, it will try, that's basically what it's trying to figure out, which one of those features matter, in what combination, nonlinear combination of those features are most useful for dividing it into what you want. I think, but if you don't know what you want, then basically anything is game, right? So it doesn't really work. But I think there's still something to be said about feature engineering, right? So you have your 200 variables. Maybe you need to sit down and just using your domain knowledge, decide if some of them are not relevant or maybe misleading, right? So it is possible to get better results by removing some of those features. Like in regression, they look at like multi-collinearity. If one of the features, for example, is always twice as the other feature, you don't want to include it because that messes up your statistics. So it's important, I guess, to do some feature engineering. But if you have labels, then the model can figure all those out by itself. But if you don't, then maybe it's very important to pick the features that you think are relevant.
Okay, so you could potentially do something like take the first variable and in a lasso framework, look at the other 199 and see what matters.
Yeah, you can do that kind of things.
And then you could potentially repeat it sequentially through all the data. I mean, that's what I see when looking at the data is there's so many of these observations that are similar.
That's why I was thinking about this master model as a way of trying to unify, like if two of them are the same, then the master model will just predict both perfectly. Like it doesn't matter that they're both the same. So the master model isn't trying to say A is the same as B. It's just trying to say, given what I know about the others and A, I can make a good prediction of A. So it's not overweighting duplicates, if that makes sense.
You can even just do something very simple, like look at the correlation coefficient between pairs of things, and whichever has.
They're all highly correlated.
So then you don't have 200 variables, you might have 5, right?
Yes.
Yeah.
So then you throw away the rest, and why would you keep the things that are redundant, right? It's not helping you.
Yeah, I mean, that's certainly a reasonable approach. It's not obvious to me how to select those 5, but
I mean, have you tried just like PCA maybe as the first?
yeah, I played around with that certainly. Yeah, and they're, I don't know, like, 4 or 5 principal components.
Okay. I
And
mean, PCA is linear, so I mean, you might be able to still do better, right? But I mean, you could even try with PCA, pick the 5 or 10 to be more conservative.
well, the interesting thing about the principal components is that when we look at those in a time series sense, there's a lot of predictability in that.
Mm-hmm. So that's a good thing, right?
I think so.
I see. So the PCA is kind of the, yeah. Principal components. So we have, sorry, just walk through me, sorry to be dumb. How would I do PCA in this? Like I know that PCA is you determine the eigenvectors and the eigenvalues, and then you take the highest values and they're your principal component. I understand all that. What's the matrix? Is it just the time series of the 200 parameters and X and Y, and you just do Gaussian elimination?
Yeah, X prime X.
So you just do Gaussian elimination to create a triangular matrix, read out the eigenvalues, and you're done. Okay, sure.
Pretty
Or you
much.
can just call a PCA function of anything. Don't do the eigenvalues and stuff yourself.
Right, but okay, so there's some predefined mechanic for doing all this.
But yeah, and the virtue of the PCAs is that I don't exactly remember the math, but I think it's the eigenvalue of the IPCA divided by the sum of the eigenvalues gives you basically the fraction of variance explained by that.
Mm-hmm.
So it has a nice statistical interpretation.
Gentlemen, I have to roll on, but I just want to share this with you. I was futzing around while we were chatting, just listening, and I went to the internet and I searched for what are some good prompts to put into Stable Diffusion, and I grabbed one of them and I'll just share it with you. So the prompt was a digital illustration of the Babel Tower, 4K detail, blah, blah, blah. And this is the stuff that comes in. So
That's pretty interesting. A lot of vegetation there.
Yeah. So what is it all
So
mean?
yeah, keep going down for a second.
That was it. That's the last one.
No, okay, so keep going down. I'm on the text. So 5.7 minutes, okay.
Yeah, to generate not one, but like many. I think there's 10 or 7 or something like that. That's 8. That's 8 images, not just one. So, and to generate one almost takes the same, right? Because it's got to encode the text, which is expensive, and then it generates, and then it can use different Cs to do the degeneration. Sorry, the decoding back into images. Yeah. So very cool. All right, guys. So Rob, can I help you with the data set in any sense? Or
Yeah, I'm still waiting for it to upload to my OneDrive. I'm doing it from home, and so it's taken a while. It's
Oh, okay. All right. Well, I'll very happily
taken over an hour so far.
I'll definitely take a run at that. And yeah, so I'll also watch that that podcast that you sent. Just make sure. I just want to make sure I've got that somewhere before we close off. Yeah, I've got that. Excellent.
That one is not the podcast. I mean, you can look for Sean Carroll podcast, but this is just one of the lectures he gave on YouTube.
Great. I didn't have a chance to talk to Rose, but I assume that she's kind of buried in her own life at the moment. But I'll try and get her to come back in at some point soon. So,
All right,
guys.
thanks everybody.
Take care.
Yep.
Bye.
Bye.